All right, lesson 6.6. Lesson 6.6 is only 4 questions. No. The first 2 questions are based on what we learned yesterday. Simply factoring out the GCF and then factoring the rest of the trinomial into those binomial factors. The second 2 or last 2 problems of this homework will be what we learned today, or what you will learn today, and that is a little bit more complicated. And when I say matchy, matchy, bobo, batchy, that's, if you were in first period, you know what I'm talking about, okay? If you weren't, you'll get there. Okay, matchy, matchy, bobo, batchy. Okay, first we're gonna factor out the GCF. This is what we did yesterday. What is the GCF of these 3 terms?
2, 3.
What? 7. Yeah, just 7. I mean, I'm assuming 84 can be divided by 7. They're telling me to factor out the GCF. I'm assuming. I'm just gonna double check on my. Yeah, 7 and 12. I should have known that. Okay, so I'm gonna factor out my GCF, and that means my GCF is a factor. I'm factoring out the GCF because the GCF is a factor. If it's a factor, we write it as a factor, meaning it's a number that is being multiplied times something else, or what I like to call the rest. Why do I call it the rest? Because after you divide each term of this trinomial by 7, you get the leftovers. I should call it the leftovers. This factor, the GCF, is one of your factor, and the rest is the leftovers. That's what I should call it, right? It's better than the rest, the leftovers. Okay, when we divide by 7, we get what?
The leftovers.
1.
1x squared.
X squared, yep. I'm just going to put x squared because the 1 can be invisible.
3x.
Huh?
Oh, sorry, I'm reading 1x.
Yeah. Yep. 1x, I'm just going to put x. Actually, I'll put that 1 there. That's going to help me later. Then what? Negative 12, very good. So remember our steps from yesterday. We factor out the GCF, which means we get GCF times the rest, or the leftovers. Then we have to factor the leftovers, the rest. We have to take this and make 2 binomial factors. So in the end, we're going to have the GCF times the binomial factor times a binomial factor. How do I know what to put in my binomial factors? What's the easy thing to slap in there? X times x, right? That'll give me my x squared. Then how do I know what numbers to put here? What do I do? No.
Sorry.
You can look at your notes from yesterday. How do I know what numbers go here?
Oh, you have to boxes.
Boxes. She's right. Boxes. And you're right too. You find out.
You multiply for whatever equals 12 also equals 1x.
Factor the rest of the binomial.
We find out what 2 numbers will multiply to get our last term, which is our C term, negative 12. And then the same 2 numbers have to add up to get the middle number, our B number, which is positive 1.
What?
Huh?
1 and 12.
1 and 12. Nope.
No, that makes sense.
Because our product is negative, one of the numbers has to be
6
negative.
6 and 2.
Okay, how can 6 and 2 get me a positive 1 now?
3 and 4.
3 and 4. 3 times 4 is 12. Which number has to be negative? Either one of them can be negative to get a negative 12 product. Which one has to be negative to get a positive 1?
The lowest one.
The lower one, very good, the 3. So the 3 has to be negative because we want to end up with a positive sum. So we have to make the bigger absolute value the positive. So it would be a -3 and a +4. So I would simply have x minus 3 for our -3 and x plus 4 for our +4. What?
Is that it?
That's it for this type of question, yeah.
Oh,
Okay, that's so much easier to exceed a class.
That's because you're probably thinking of what I was starting to do at the very end of class.
Oh, yeah.
That is where we're gonna have some, you know,
Yeah.
confusion. You need help with yours?
This makes sense, right? I put this in and it said it's wrong.
Let me see. All right, guys, take us, I'll come over there. Take a second to do your numbers, and then I'll move on to the next question. Where's the original? That's because a -6 and a +3 would get you a -3 here. Here you go.
Strawberry shortcake.
Okay. That sounds delicious right now.
When this was one.
Sure.
So -7 times -3 -10.
-7 times -3? What?
That's what it is.
It's so funny if you're
You're thinking of adding.
What?
If you add a 7 and a -7 and a -3, you'll get a -10, but we're trying to multiply numbers. Think of the factor pairs. See, what you're gonna wanna do is you're gonna wanna make your boxes nice and long. Since you're having trouble,
These are crummy.
you're just gonna start listing pairs. Don't worry about the negative right now. What are some factor pairs that would make 10? Good. 2 and 5.
really solid.
What else? You absolutely could, and that's what the answer is. But sometimes just drawing that box kind of helps your brain process it better. Even if you don't end up filling up that box with all the possibilities. You see how like just writing it out and telling your brain that you're gonna give it space to do it makes your brain go, oh, okay, I can do this.
Pencil. I'll give you
Girls,
my pencil.
girls, sit.
She took my pencil. Yeah.
Listen. I have enough of that with my own children. We're not bringing that into my workplace, okay? You guys are teenagers. Do not act like elementary school kids. I'm waiting. Are you ready? You got it right? Okay, good. Number 2 is the exact same process. Numbers 1 and 2 are literally the same questions, just different numbers. Again, factoring out the GCF. I was thinking, should I just skip this one because I just did an example like this? Nah, I'll do it again. It's good to have a second example. So, same steps as before. We're going to rewrite this as the GCF times the rest, or the leftovers. What's the GCF? 8. How do I get the rest, or the leftovers? Yep, divide by 8. And what does that look like here? Good. For x. And then, is this the number negative? Is this another negative 12? It's 96 divided by 8, negative 12? I mean, negative 12? Okay. Okay, and then my very last step is to take this trinomial, or the rest, the leftovers, and break that up, or factor that out, so that I have 2 binomial factors instead of a trinomial product. So, even though technically this was one of the factors, I made this comparison in one of the classes yesterday, and I want to show you again. Let's say, like this original trinomial, let's compare it to something super simple, like the number 20. Let's say it says factor out a 20, or not factor out, factor a 20. There are a couple of different ways I could break down a 20 into factors, but just for my demonstration purposes, I'm gonna choose to break it down into 2 times 10. Do you agree that 20 can be broken down into 2 factors, right? Do you agree that 2 cannot be broken down any further? Mm-hmm. Do you agree that 10 can be broken down further? Mm-hmm. What can it be broken down into? Yep, so I can do 2 times 5. 2 cannot be broken down any further, and 5 cannot be broken down any further. What I'm trying to show you is, when we originally factor the trinomial, we're breaking it down into its GCF and the rest. So even though 2 isn't a GCF, because we're just dealing with one number, I'm just showing that you can break a product, okay? So this is our product broken down into 2 factors, the GCF and the rest. This is a product broken down into 2 factors, 2 and 10. The GCF is done. The rest can be broken down again into 2 factors.
Wait, so 5 can be broken down into 3 and 2?
Not by multiplication. This is a factor tree. Factors make a product. 5 is not the product of 2 and 3, it's the sum. You get it now?
Kind of.
Have you ever seen a factor tree before?
I haven't done one in years.
We did that like a couple of years ago.
Yeah, we just did it a couple of lessons ago. A factor tree is a tree that grows factor branches. A factor is part of a multiplication problem. 2 plus 3 equals 5 is an addition problem. You're barking up the wrong tree. Get it?
Why are you barking at a tree, Callie?
Yeah, Callie. Stop barking up trees, Callie.
Bark at your tree.
All right, so what I'm saying is, when you break down a product, this branch cannot be broken down anymore, but this one can. That's just what we're doing here. We're breaking down this product into 2 factors. Then we take one of the factors that can be broken down even further, we break it up again. So I used 20 as an example because I picked a number that will end up breaking up into 3 factors, 2 times 2 times 5. And this will break up into 3 factors, 8 times a binomial times a binomial. And that's all we can do. So how do we break up this trinomial into 2 binomial factors? What's the easy part? Yep, your x times x. And then how do we find the other numbers here? Boxes. Blank times blank equals negative 12. Blank plus blank equals positive 4. Huh? I need two numbers that multiply to get a negative 12. That means one of the numbers is going to be negative. One of the numbers is going to be negative, but I'm going to end up with a positive sum. That means which number? The lower one has to be negative and the higher one has to be positive. Okay, so what are the... So those multiply to get 12, but they don't add to get 4.
62.
6 and 2. 6 times 2 is negative, 6 times 2 is 12. One of them has to be negative. Which one has to be? Yeah, very good. A negative 2 to get a positive 4, and then that would mean that as well. So we have a positive 6, so plus 6, and a minus 2, and then we are done. Do you guys need a minute to work on yours? You already did number 2? Was it the same one as mine? You already did it? You guys ready to move on? Do you need a minute back there?
I need a minute.
Okay. To do yours?
Yeah. I'm still confused on the first one.
Okay.
I'll try
We don't call it intensive math for nothing. This is intense. Okay. So that's your first one. You are factoring out the 5. Squared, 6x, and 16. Okay, good. You got your boxes. You're trying to get a negative 16 as a product. I don't worry about the negatives until the end. When you're trying to get your product, just think about positive numbers that get 16.
Oh my gosh.
What?
I'm trying to get it now.
Okay. Sometimes it just takes a little wiggling around in your brain,
Hold on, is this-
playing around with the numbers.
Is this right?
Yeah, yes,
Okay.
that is correct. Yep. Because it doesn't matter which one's negative to get the negative product, but it does matter which one's negative to get your sum. All right, so I'm going to move on to number 3, and then Emily,
Yeah.
pay attention to what I do, and then you can go back to your number 2 after I'm done, okay? Because I don't want you to be working on your number 2 while I'm moving on to the other ones, and then you're like, I don't get how to do the last ones. Pay attention to what I'm doing, okay?
Okay.
All right, so is this number 3? No, it's not. Okay. So we're going to factor this expression. Again, if you haven't had my class yet, you have not learned the magic of matchy, matchy, bobo, batchy, but don't worry, Zach. Do you remember matchy, matchy, bobo, batchy?
Isn't it last year?
Yeah.
Yeah.
You don't remember what it means, you just remember matchy, matchy, bobo, batchy. If you learned nothing in this class this year, other than one thing, it's matchy, matchy, bobo, batchy. You might not remember what it means, how it applies, but you'll remember matchy, matchy, bobo, batchy. All right, so when we have an expression where we say, when A doesn't equal 1, what do I mean by A? What's A?
Oh, A is the number in front of the X at the start.
Yeah, it's in front of it's actually in front of the x squared, okay? So it's the coefficient of your first term, the x squared term. So this would be ax squared plus bx plus c. This is just like the standard form of it. A, b, and c represent whatever numbers are going to be in your expression, but in a quadratic, you'll always have x squared and x, okay? Most of the time. This could change, but we won't go into that. You'll always have an x squared and your other terms, whether they're invisible or not. We'll go into that another time. But we have a, b, and c. That's what we call these 3 numbers. In previous examples, we have had, and I did go over this a little bit yesterday in class with everybody at the very end. We talked about how this used to be just a 1. It used to be an invisible 1. And we didn't have to worry about it. Now that it exists and we have a value that is not equal to 1, but it's 2 or 3 or 4 or 5 or 6, we have to account for it in our binomial factors. So when we break this down into 2 binomial factors, it can't just be x and x, because
x times x is x squared. It's not 2x squared. So something has to be involved here to create the 2x squared. Now, what we learned yesterday is we are going to do the boxes step. Abby, I can tell that you're distracted, so whatever you're distracted by, stop. Okay? We are going to find two numbers that equal a product and the same two numbers that equal a sum. The good news is the sum is the same as the other examples that we've done. We are looking for B, or a positive 5. But the product isn't just this number anymore. What is it?
2.3.
Yep, it's A and C multiplied together. So when you multiply A, which is your 2, and C, which is your 3, you're going to get the product 6. Now, it doesn't mean that 2 and 3 are your special numbers, although they could be. Hey, they are. Interesting. It just means that first you're going to multiply them together to get your product. Then you're going to decide what two numbers multiply to get 6 and add to get 5. Just so you know, the fact that these numbers that are going to go here, the fact that they happen to be the same as A and C is just a coincidence. It won't work for most of the problems that you do. Okay, so what are the missing numbers here?
Two, 3, 2.
Yeah, Emily, I just said the fact that 2 and 3 are the missing numbers is just a coincidence. Then I said, what are the missing numbers? And you're like, 1 and 6. It's just a coincidence, but it is 2 and 3. Yeah.
Is it a coincidence? Because everybody has it like that. Like Emily has it, mine has it.
No.
I'm on number 4.
Oh, that's because they design this specific question. Even though they generate different numbers, they're designing it to be the easiest example possible for this. So they're giving you the lowest, easiest numbers. When I chose this from the book to include in your homework, I went to the easiest example possible. You'll see that the next example, it's not gonna work out that way. Sometimes it will, sometimes it won't. The easiest problems it will, the harder problems it won't. But everybody probably has a similar problem that will also work out to be the numbers that you need will happen to be A and C. It won't always be that way. Okay, anyway, so we have our numbers, but here's where we left off yesterday in our lesson, and I didn't go into it, but in class, what we have to do is take this and rewrite it. I'm gonna write 2x squared. I'm also gonna have my 3 at the end, but I'm gonna rewrite this positive 5x as 2 terms. Am I allowed to do that? Am I allowed to rewrite something as a combination of other things? Like, if you say, bring me 5 cookies, am I allowed to bring you 2 cookies and 3 cookies? Because that's bringing you 5 cookies, right?
I would love to be wrong.
I know, wouldn't that be nice? So you say, hey, bring me 5 cookies. And I'm like, sure, here's 2 and here's 3. Would you be like, I said, bring me 5 cookies? And I'm like, I am, here's 2 and here's 3. I said, no, that would be really sad and mean. Don't ever do that to me if I bring you 2 and 3 cookies. That is 5. What if you asked me for 5 cookies and I say, okay, yeah, here's 5 cookies, here's 1 and here's 4. Would you be like, excuse me, I asked for 5 cookies. Yeah, here's 1 and here's 4. What if you're like, I'll give you 5 cookies, here's 5 and here's none? That would be 5 also, right? So do you agree that I can rewrite 5x as 2x and 3x? Do you agree that I'm allowed to do that? Do you agree that this trinomial, 2x squared plus 5x plus 3x, is the exact same thing, or the exact same value, as this 4-term polynomial? because the only thing that changed is I rewrote the 5x as a combination of 2x and 3x, because 2x and 3x equals 5x. You guys get it? Now, why would I want to rewrite it and make it look more complicated? Because, no, we actually uncombined. We actually broke it apart. It's like the opposite of combining like terms. We used like terms to break up this sum into 2. Now, what we're doing here is we're trying to get, it's called grouping. So we're trying to break this up so that, I just kind of usually do just like a little dotted line there. So that what we really have is 2x squared plus 2x grouped together plus 3x plus 3 grouped together. Do you agree that that's the same thing as all of them? It's okay to group them. Those parentheses don't really mean anything, it's just grouping. It's saying, hey, you hang out with this guy, you hang out with this guy, but we're all in the same room together, okay? Here's the next step. You're gonna take one of your groups and you're going to factor out the GCF. What's the GCF of 2x squared and 2x? Are you zoning out right now? Are you zoning out a little bit? Me too. Y'all that talk about cookies, right? I could go for 5 cookies. Oh, that's
I had
good.
ramen for breakfast.
Ramen? Let's not, okay? What's the GCF of 2x squared and 2x?
1.
2 is half of it.
1.
2 is half of it. What's the other half?
1.
Yep. So the GCF is 2x. I'm factoring it out. Remember, factoring it out means put the GCF as a factor, and then something else is going to be the other factor. What's going to be the other factor? The rest after you divide. So what is the first part of this binomial? What's 2x squared divided by 2x? X. What's 2x over 2x? 1. So plus 1. And then we're just going to leave that there for a second. We're going to leave it there for a second. And we're going to move over to here. And we're going to factor out the GCF over here too. Now again, it's plus. I'm just going to plus. What's the GCF on this side? 3. What's the rest? X plus 1. Matchy, matchy, bobo, batchy. That's our celebration rhyme. When you do this and you get a matchy, matchy, bobo, batchy, that means you did it right. If you get the same binomial here as here, you did it correctly. Now, how do we get our final answer? Are you breathing in while you're talking? You know, like when people do that? Oh, that's so weird. Okay, stop. Okay. So your final answer, I know this is going to sound crazy, your final answer is going to be your matchy as one of your binomials and your GCFs as your other binomial.
I did not. It's weird, bro.
So your final answer, this guy broken down into 2 binomial factors, will be your matchy-matchy as a binomial factor and your GCFs combined as your other binomial factor. So your matchy and your GCFs. That's what you're going to end up with. And the reason we're allowed to do that is what I would call, and it's not a real math term, is the undistributive property. Because technically, if you were to take these binomials and use the distributive property to multiply them, you would be taking your 2x and multiplying it times x plus 1. And then you would be taking your 3 and also multiplying it times x plus 1. So that would be distributing it, but to get from here to here, we're going backwards. It's undistributing. Yeah?
Can you read mine? All my math makes sense to me. I can get it all, but it says it's wrong.
Okay, so I'm gonna end the video here, and I'm gonna go around and help everybody with their own thing.
What about 4?
4 is the exact same type of problem. So I just did an example of it that I'll help you guys individually.